Hello guys, welcome to my channel. My name is Winger. Today I would like to share with you what I've been working on for a while. It is development of HMI and SCADA using OPCUA and Python. So what is the purpose of this project? As an engineering guy trying to go into tech, I decided to make this a project because being in engineering, electrical engineering per se, I understand that HMIs and SCADAs are software that interacts with machines, and I feel like developing this kind of software will be an improvement for engineering and technology as a whole. Let me just show you a quick demonstration of what I am talking about here. So I'll head over to my POSIX application. So here I have a POSIX installed on my Windows PC. I'm using a Raspberry Pi as a controller. As you can see, I have set up a ladder logic and I have downloaded it onto the controller. So I'll just launch my application, the software that I developed. So I have my software here and I want you to observe as I interact my software with my device, with my controller. So first thing first, I'm going to input a set value for my counter here. This is my counter and this is the set value. So from the software, I'm going to input a set value and I want you to observe how this number changes. So I'm going to type in 10 and submit. So as you can see, it sends the information, it sends the data to my controller, which means it is working fine. So basically what I'm doing is that I've created a software using Python. I use Tkinter as a GUI library to then I created a server using OPCUA, and then I created a client and I embedded the client into the Python language that I've written, the Python code that I've written. Basically, that is what I've done here. If I click on this main switch, watch as this start button respond to the switch. As you can see, it is coming on and it is going off. So if I leave it on and click this, the stop button will respond to it as well. And I have linked the output of my relay here to the input of my counter, which means the more I click this, the more the current value increases. And when the current value gets to the set value, I should have an output here. So just watch closely as I do this. Now the number is increasing and we are on 9 now. So I have just one more time to click and we should have an output at the end of the relay. So that's it. You can see there is an output at the end of my relay. Basically on the controller, I am getting outputs on my GPIO, on the GPIO of my Raspberry. So let me give you a quick introduction about Raspberry. What is Raspberry? A Raspberry Pi is the single board computer It is a single board computer. So basically, it is a small and cheap computer that has a GPIO. The GPIO serves as the input and the output. So when we compare this to PLC, which is the programmable logic controller, I don't see much difference apart from the ruggedity. You know, PLC is designed to be rugged and withstand industrial hazard. So with some modifications, I think we can use this as a PLC. As a matter of fact, I've seen people convert Raspberry to a PLC, and I've seen one or two people use this for industrial purpose. So when you have your means of communication, in my case, I'm using a Wi-Fi, so you can choose to use Ethernet also. But in my case, I'm using a Wi-Fi. Talking about OPCUA, it goes as far as using internet. You can have your factory in a location and you'll be in another location and you'll be controlling, you'll be accessing your machines, you will be seeing the data, the inputs, the outputs, and everything on your device. Your device can be a phone, it could be a PC, any computer. So that is the basic advantage with OPCUA. So what I'm trying to implement here is for uh, guys in engineering. Sometimes you don't have enough funds to acquire a PLC. The PLC is expensive, the software is expensive. This could be a solution. You know, we could we could modify Raspberry to the extent that it will serve a purpose of a PLC, and it won't be too expensive. It will be easy for people without much funds to access. And with programming languages like Python, Node-RED, and others, C++, you'll be able to develop your own HMI without waiting for the, 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 the manufacturer of a PLC to give you software to configure your PLC and create an HMI. So basically, that is my purpose for this project. So this is the official website of Raspberry Pi. You can head over to the website to learn more about Raspberry Pi. So after getting your Raspberry Pi, in my case, I'm using a Raspberry Pi 4B. So after getting your Raspberry Pi, you need to download an OS. You need to download an OS to install on your Raspberry Pi. There are different versions here. So choose the one that suits you. Download the OS on your Windows PC and get Raspberry Pi OS imager. So the purpose of the imager is to flash the OS into your Raspberry Pi. I'm going to open the imager for you to see what it looks like. So as you can see, it looks like what I have on their website also. So basically, you insert your storage device. It could be your memory card, it could be your hard drive or SSD. You insert it into your Windows PC. First and first, you erase it. You choose the storage device. I don't have any device here, but you have a device, you should see one here. You select it and then you click on write. After that, then you select, is it that you download the OS from this application, or you use the one that you've downloaded on your PC. You select it, choose the storage device, and then you write. So after writing that, you get a notification that it is done. You eject the storage device, insert it into the Raspberry Pi, and power up the Raspberry Pi. So for this process, you are going to need a monitor and a keyboard. there are ways to go around that without using monitors and keyboard, but I won't be getting into details. So basically, after getting your monitor and keyboard ready, you fire up and wait for the Raspberry Pi to install. After the OS has been successfully installed, you navigate through your Raspberry Pi desktop and either through the terminal or through the. Okay, let me show you what my Raspberry Pi looks like. I'm using a VNC viewer to access my Raspberry Pi through wireless. So this is what my desktop look like. It's just like a normal desktop, like a normal PC. There are options for you to access. You can use the terminal or the applications and access whatever you want. As you can see, I'm using a Wi-Fi as a means of communication. I use my phone to link. I use my phone to link both my Raspberry Pi and my Windows PC together. So I use my phone as a hotspot. You know, you can use Ethernet cable, but in my case I'm using Wi-Fi, which means I'm controlling and accessing my Raspberry Pi wirelessly. So basically that is what you need. So after getting your Raspberry Pi ready, the next thing you need to do is to enable SSH and VNC viewer. This is what will give you access into the Raspberry Pi. So after getting that, then you need to install a courses. Head over to the courses official website, get the application installed, install courses, and you're also going to need courses Raspberry Pi controller. Give me a minute, please. So I'm going to the courses official website now. This is where you get your software downloaded. Um, okay, this is where you get the software downloaded. Download the software, and then you can download a package for Raspberry Pi. This is Raspberry Pi controller. So allow it to load. This is the control for the Raspberry Pi. You install this alongside your PostSys application. So when you have that set on your system, you can come here to let me close it. So and come here to tools. The system is hanging. Let me give it some minutes. So basically you come here to tools and then you update the Raspberry Pi. Updates the Raspberry Pi. So this is how you connect to your Raspberry Pi. Um, you'd have 4 minutes. You'd have something like this when you want to update your Raspberry Pi. It's asked for username, password, and you scan for your IP. Yes, you need an IP, the IP address of your Raspberry Pi to log in. After getting that, you can head over to Advanced IP Scanner to download the software that allows you to scan the IP address of your Raspberry Pi. I can make another video on that, but I won't be getting into that for now, just to save time. uh, after getting your IP ready and your desktop, your Raspberry desktop ready and all set, the next thing to do is to connect. So you connect by inputting your username, password. You scan for the IP. As you can see, I have my IP here. I click it. You click on install. Yes, you install the Raspberry update, and then you start the runtime. After starting the runtime, then you can start your project. You can create your ladder logic and then download it into your device. So basically, that is most of the works. You create your ladder logic, link your relays to your GPIOs. Then one more thing, yeah, you need this. You need this to to access OPCUA, to enable OPCUA on the device. So you need to come here and check the necessary things that you're going to use. In my case, I have the counter, CL, current value, relay 1. Those things are the values that I have here. The stop, the start, the counter, the relay 1, relay 2, and all that. So with that being said, basically, think I've shown you how you can create your own software. So in the next video, I will go more into details on how you create a server and a client, and uh, how you create a server and a client. Client, which is going to be your HMI and SCADA, depending on what you want, depending on how far you are willing to go on designing it. So thank you for staying tuned. Catch you in my next video.